For problem 1D, I'm told the lines L1 and L2 intersect at this coordinate at point C, and the coordinate is given as 8, 11, Z. And I want to find Z. So let's think about what's going on here. I've got L1 and I've got L2, and right here in this diagram, this is the point C. So what I can do here is I can take really either equation for L1 or L2, and I'm going to use just one of those to try and figure out the other two parts of this point C. I chose to use L1 here. You could have done the same process with L2, but I'm going to go forward with L1. If this is my vector equation, basically what I want to find out is when this vector equals the position vector 8, 11, Z, since that's where the coordinate C is. Now what I can do here is I can say, well, I can figure out what my scalar t value should be just by kind of isolating the x component and the y component and the z component. So it's kind of like we're thinking in the parametric world for a second here. So let me write out what my x components equations are. So we're going to kind of go parametric to help me with this one. And the goal of using parametric is that I can kind of isolate out each component, x and y and z. So x is going to equal 4 plus 2t, y is going to equal -1 plus 6t, and z is going to equal 3 minus 2t. And I just grabbed basically this 4 and this 2 and this -1 and this 6, just converting to parametric. Now I know that my component for the x is equal to 8, so I want to figure out what is the t value when x equals 8. And similarly, I'm going to do the same thing for the y component. I know that the y value is 11, so I'm going to set this equal to 11. So 11 should equal -1 plus 6t. If I solve both of these for t, I in fact get the same thing. I get that t equals 2. And you can check that. 2 times 2 is 4, plus 4 is 8. 6 times 2 is 12, plus -1 is 11. That should be the same same t value as this t right here. Since the t is the scalar value multiplied by the entire directional vector, I can't have like different t's applying to the same direction vector. So if my t is 2, then I can find my z by plugging in 2 for this t. So z will equal 3 minus 2 times 2, or this is 3 minus 4. So then the z component must equal -1.